we are trying to create this SAF to be exactly like jet fuel. Honestly, SAF seems to be the only way right now. I don't know if people are willing to pay maybe like 2 or 3 times the cost of the ticket for burning SAF.
Hello, I'm Ben Sampson, editor of Aerospace Testing International, the world's leading magazine dedicated to the application of testing, evaluation, and inspection in the aerospace industry. I'd like to welcome you to this episode of the Testing Talk Podcast from ATI. Sustainable aviation fuel, or SAF, has risen up many people's agendas recently again in aviation. It's being mooted as the number one way to reduce the sector's emissions. I thought it would be a good time to speak to an expert about SAF from a more technical point of view. Francesco Di Sabatino, who is group leader in the Combustion for Power and Propulsion Group at the Southwest Research Institute, is that expert. He and his researchers have just completed a test program comparing the performance and emissions of SAF, e-fuel and Jet A to each other, and plan to make results public soon. He has some early insights to share from the comparison and some thoughts on how we can enhance SAF to make it more appealing to aircraft operators that I think you will find interesting. So now, wherever you are and whatever you're doing, it's time to listen back to my interview with Francesco Di Sabatino from the Southwest Research Institute. What's the weather like in Texas? I bet it's warm and sunny.
Hello, Ben. Thanks for having me. It's still kind of sunny, a little bit chill in the morning, so we're expecting a little bit of cold weather, but it's getting very nice.
Great. We're here to talk today about a project that you've recently done for SWI, a research project. First, could you just tell me a little bit about yourself and a little bit about SWRI, where the company sits, what it does, what you do for them?
Sure. So I am a group leader here at Southwest Research Institute. I lead the Advanced Combustion for Power and Propulsion Group. As the name says, we do a lot of stuff related to power and propulsion, mainly in the field of combustion. Southwest Research Institute is a non-profit organization, a research institution. It's been around for more than 70 years, so been around for quite some time. Always here in San Antonio. That is kind of in the center of Texas, more or less. Southwest really does everything from deep sea to deep space. This is our motto, really. So we develop submersible for the Navy, I believe, as well as spacecraft for NASA. Combustion is just a part of all this stuff. So we really do a lot of different things. And Southwest Research Institute really lives in what we call the Valley of Death. So TRL, from TRL 2 to 3 to TRL 7 to 8. So we kind of help our clients to develop a product, or we develop product for our clients, try to bring it to commercialization. We do not sell really any product. We are more doing kind of research for clients or with the government as well.
You're not really blue skies research so much. It's more sort of research and testing, which is closer to industry, right?
Correct. We have a very, very small part of our institute that does kind of what we call basic research or basic science, but we mostly work with the industry, yes.
And now you've recently done a project about sustainable aviation fuel, which has compared it to e-fuels and normal jet fuel. Can you just talk me through that, what you did and why you did it, what you were trying to find out?
Sure. So I've been exposed to sustainable aviation fuel before joining Southwest Research Institute, and I wanted to kind of continue that research here as well, mainly because my exposure was kind of showed me that there is a lot to do, a lot of like work that has to be done on SAF, right? Yes, there are companies producing SAF, but the amount of information available in the literature are very, very limited. Mainly because all these companies are very jealous of their product, rightfully so, I would say, as well as, for example, on my side, engine testing, the data available is very, very limited because lots of the large OEMs don't really want to share this data or things in that regard. So the idea here was really to try to produce a data set that could be used by everybody in the world to maybe help them developing the new fuel or kind of starting develop new fuels. Or for example, if they're working on engine testing, kind of having a starting point for that. So that was the overarching idea. So then I started looking inside our institute who was also working on SAF, and I found other groups here that do SAF production as well as SAF characterization, like for the ASTM certification. And then I put together all these people to try to develop a program, a project to kind of have a very complete data set to send to the public. And that's what we have done. So we produce our own SAF that we then blend with jet fuel, Jet A. We characterize this blend, plus we characterize also commercial available fuel, SAF, as well as a commercial available Jet A. Then we test all these three fuel in our jet engine, and we measured engine performance and pollutant emission, both gaseous emissions as well as particulate emissions. We noticed quite interesting stuff that hopefully will be published very soon in a journal paper. But again, the idea here is to really produce data set that could be used by the general public.
So you identified perhaps a lack of data and knowledge about SAF within industry, and you've attempted to fill that gap by producing your own fuels and then testing them all in-house, right?
Yes, all in-house,
Yeah.
yes.
Okay, fantastic. All right. So can you tell me a little bit more about the production? Let's talk about the testing in a moment, because that's what we're interested in, and the results. But producing that amount of fuel, and I mean, how did you go about that? I mean, how do you do that and you're producing SAF and e-fuel, which is fuel from water, isn't it? Electrolysis of water.
There can be a lot of different sources. So unfortunately, I cannot really talk about the technology itself because that's proprietary technology. But I can guide you kind of through the step that we followed. To start with, there can be different sources for e-fuels. We got a feedstock for that from a client that generously gave it to us. Because even getting a feedstock, it's not simple, and it's not something you can find on online, for example. It's very rare. So then we hydrotreated that feedstock. So we kind of produce a liquid fuel out of it that we'll like add the hydrogen and heat, and we also have a catalytic process. All of these remove all the impurities, so oxygen and other things that can be in the original feedstock. After that, we do isomerization, so try to improve the quality of the fuel, right? Because whatever you get from the first step is not the right quality. And then all these processes to improve quality until you get to the distillation, and that's where you actually get the kind of the jet fuel quality that you need for putting into a jet engine. So that's the process that we followed. And let me tell you, it's not a cheap process, especially if you do like for small scales. It's expensive. So.
Yeah, that was my question there, actually.
Yes.
Sorry for cutting across you, Francesco. It sounds like a long and expensive process to do. And I mean, do you need a lot of this fuel to do this?
No, we don't need a lot, really. So we can do tests in our system for less than a barrel of fuel. So 50 gallons. So we didn't have to produce a lot. Our blend ended up being like around 15% SAF and then 85% Jet A. So we didn't really need to have a lot. But even that small amount was quite expensive because, again, we're not like producing fuel at scale, right? We do have that capability. We're not doing it for that project. But yeah, if you produce a small scale, it's usually expensive.
Okay. So let's talk a bit about the testing. I mean, how did you test? What tests did you put the different fuels through? I mean, how did you ensure that you could compare the data sets from each fuel?
Yes. So yes, of course, there are many ways that you can do these tests, right? We investigated different ways, and we had to settle with the one that was feasible for us. It might not be the best way of comparing the fuels, but that was working for us. So the reality was that we were comparing at different throttle conditions, engine throttle conditions. So fixed throttle and just see what the engine does for the different fuels. Again, there are other ways. This was the way we decided due to several limitations as well we have on our system. We tested the three fuels one after the other, and at the same time we actually purge all the lines, and and also try to purge the lines inside the engines with nitrogen, as well as the actual fuel, the next fuel, right? We fuel that fuel just without burning, just to flash the line and remove the previous fuel. We measured engine performance based on, for example, airflow rate that was going through the engine, rotational speed of compressor and turbine, pressure and temperature along the engines, like compressor discharge, turbine inlet, turbine outlet temperature, things like that, and pressure as well. We also measure emissions. We measure gaseous emissions in terms of CO, CO2, oxygen, if you call it that as an emission, and NOx, nitrogen oxides, sulfur oxides. And we also measure particulate matter, volatile and non-volatile, specifically soot. And we also did a quite interesting analysis of soot particles. We collect the soot particles on specific filters. Then we analyze with the scanning electron microscope, so we could go very, very in detail of the particulate and try to see how the particulates look like, soot look like, as well as if there are kind of other components on the surface of the particle. So that's what we've done for testing.
What was the trickiest part, or what was the cleverest part of the test to set up? Because you're testing, you've got an engine running on a stand, right?
Yes.
In the lab, okay. And then, what was the trickiest part to get right, or measurement to take?
Yes, I would say one thing was also trying to get similar humidity levels, because humidity swings quite a lot here in Texas. But also try to collect the exhaust gases very close to the engine. It was tricky. For material compatibility, the gases were very hot, as well as we were really trying to collect all of the gases that were coming from the engine core and not from the dilution. So try to really have whatever was coming out from the combustor. And so for that, we had to kind of design a custom-made probe that we installed just outside the engine.
What did you find out then? Was there any differences or anything that surprised you between the emissions of each type of fuel?
Yes, honestly, lots of them were kind of expected, right? So in terms of engine performance, we didn't see substantial differences within the fuels. But again, that was expected because SAF blends are designed to be drop-in, so are designed to be somewhat similar to a jet fuel. What we observed in terms of emission is that sulfur emissions were much, much smaller compared to Jet A. Then that was kind of expected because the sulfur in the fuel comes from the fact that the fuel comes from oil, so it's present into the oil as well, into the process to get to the jet fuel. While that's not the case for SAF, right? And there's no sulfur to begin with, so sulfur level to begin with in the fuel were very, very limited. Other thing that we observed, soot particles were substantially less. That was somewhat expected because aromatics content were less for the SAF. We observed different NOx emissions. That was somewhat unexpected. We are still working on trying to understand why that was the case, but we observed substantial difference between NOx, between Jet A and SAF. So that's a very interesting result that we are still kind of investigating on why that's the case. Unfortunately, our system, we didn't have a lot of access to the actual combustion process, right? Because it was inside the engine. So we are limiting information on what really was going on into the combustor itself, where the NOx is spark. So that's why it's taking a little longer to understand why we have these differences in NOx.
Now, you had an e-fuel you were testing as well. You mentioned SAF there. Are you describing the e-fuel as SAF? Was there any differences between that fuel that you made there?
So compared to the commercially available SAF that we bought on the market, there was some small differences, but at the end, the end product is very similar, right? It's not like we are getting to something that is jet-like fuel, so jet fuel-like. So we were not expecting a substantial difference. So
in terms of, sorry, Francesco, in terms
Sure.
of the composition of this fuel and the composition of the emissions and the particulates that you're getting, you're really just seeing environmental benefits at this level.
Correct.
Is that what you? Yeah.
Correct.
Okay. All right.
But I would say I want to add one thing. I think we really have a kind of an opportunity, right? Because right now we are trying to create this SAF to be exactly like jet fuel. But we have an opportunity here. We have practically full control on the composition of the fuel. So why not to produce this fuel in such a way that can maybe enhance the performance of the engine? So maybe you can end up having like less fuel consumption. So overall, you get lower emissions, but also more efficiency. So less fuel consumed, lots of different things. I know that this is really kind of not possible at the moment for safety reasons. But I mean, there is an opportunity here. And I think we should look at that in the future. Say, okay, maybe we should move away from try to be exactly the same as a Jet A and try to be to generate a fuel that has better performance, for example.
How might you do that?
I mean, you can definitely control the chemical composition of your fuel, right? So changing the chemical composition, you can change performance and stuff. Like fuels are composed by major components such as alkanes, aromatics, and I'm not a chemical engineer, but I'm somewhat familiar with that. So you can change the kind of the relative percentage of all of this stuff to get better performance. However, we're probably like several, maybe decades away from that. But I just want to highlight this opportunity that we're really looking into making something that is same as Jet A, but maybe we should look at something that it's better than Jet A.
So will you be doing any follow-up studies or research testing?
So yes, we have actually, I cannot really talk about that, the details, but we have a follow-up studies next year, 2026. And we are also kind of establishing kind of a more structured program here at Southwest to keep working on SAF, like all together, the various groups that participated. Maybe in the future, organizing kind of a workshop here on site, to bring like people from the various aspects of SAF, like production, characterization, and testing, to bring them on site and kind of put these people in the same room and try to kind of come up with good results there.
So what's the main message, the main implication that you would say that in that there is no real difference between these types of fuels to airplane operators, to aircraft operators?
In terms of performance, yes, there's no main differences, right? But that's by design, right? That's how the SAF have been designed in the past years. In terms of emission, there is a difference, right? So we definitely should keep pushing to use SAF. I think I forgot to mention, we don't have an explanation for that at the moment, but also the smell of kind of burning SAF and burning Jet A was different. So there was much less smell from burning SAF than burning Jet A. So that's also a good thing for the airport, for example, whoever lives around the airport. But the message here is really, we need to keep working on SAF. We need to keep kind of developing data sets that can be used by everybody. I'm really advocating for kind of sharing data because to me, that's the only way of kind of getting to a point that you can demonstrate that SAF is valuable and it gives a less emissions, so it's good for everybody.
Thanks, Francesco. It's a really interesting study, and I'm pleased we've been able to catch up about it. I just got a one or two final questions really about the sort of more general landscape of the industry. And yeah, I mean there's some tough questions. Yeah, there's some tough questions that perhaps we were beyond me and you answering over the next couple of minutes for at least. But I just wouldn't mind your thoughts on them if that's okay. I mean, there are some barriers to the introduction of SAF that aren't perhaps chemical and engineering related. I mean, I'm talking here mainly about the cost and the incentive to scale up. Do you see SAF in general for the industry as a practical way to reduce emissions? Do you think it's a good idea that we can do?
Yes, I mean, I think we should look at all technologies and see which one is the most valuable. From my experience, this is my personal take on this, is that honestly, SAF seems to be the only way right now. Like other option, for example, hydrogen, don't seems to be very feasible at this stage. SAF is exactly the same as a Jet A, so we know how to handle Jet A, we know how to handle SAF, so it seems to be the way. However, we, in my opinion, need to create a market for SAF, and the market is not really there. So that's one of the reasons why the price is very high. Even getting like a new production facility is extremely expensive. If there is no market for the SAF because we're not creating it, then there's no way that we're gonna use it. A market can be created by kind of incentive from the government. There might be, for example, in Europe, there are mandates for that. That's another way. But without a market, the stuff, I mean, it's going to stay there because it's going to be too expensive and airlines won't be able to afford it. Or if they are able to afford it, then the customer will have to pay for it. And I don't know if people are willing to pay maybe like 2 or 3 times the cost of the ticket for burning SAF. So that's, yeah.
So going back to what you just said about at the moment we're trying to match Jet A with SAF, use it as a drop-in fuel. Do you think there's scope to make SAF even better than jet fuel? That could be a way to tempt people to use it.
Yes, that could be a way. Sure, I think that's a good idea. However, again, the cost is probably won't be competitive anyway. So, and again, I think it's good to make it. We should make it better, but we should also think about the cost of making it.
Just finally, do you think there's any you mentioned some of the ASTM standards and that you were working towards, and do you think there's any? I don't know about your knowledge about these, but do you think that they're working to introduce SAF to help SAF, be into use, or is there anything different that they could do to help it?
No, I think it's a very difficult kind of field, right? Because safety is paramount. It's nothing more important than safety for aircraft. So that's why it's taking very long time. So the industry has been risk adverse since it's been born. So I think the combination of all these things make things to go slowly, but maybe it's a good thing they're going slowly, right? Because then we are sure that we're going to get a product that is safe and can be burned properly. But this safety also comes with a cost. So again, it's all of a balance with all these factors that kind of will have to be kind of on the plus side at some point for us to kind of have using SAF.
But studies like yours help to increase awareness that the fuel is it can be used and is relatively harmless in aircraft, and is harmless in aircraft, and perhaps even has environmental benefits and scope to be used beyond normal jet fuel.
Yes, correct. That's kind of my idea as well, right? To just show the benefits, to show like there is a real proper measurement that shows the emissions are less with the same performance. So that's kind of one of the goals of the project.
So will the data be freely available at some point? Or you mentioned...
Yes, it's gonna be an open source probably. So yeah, and like as soon as the paper is published, we're gonna also publish on our website and all the other things. So people will we have free access to it.
You know what that will be? Not to put pressure on you.
Yeah. It's a very large paper, so it takes time.
All right, great. Okay. Well, Francesco, thank you again for your time.
Thank you.
And talking me through the project. That sounds very interesting. I'm sure our listeners will be. So I hope you enjoyed this conversation with Francesco from the Southwest Research Institute. Join us again for another episode of the Testing Talk podcast from ATI soon. In the meantime, stay in touch with us at aerospace-testing-international.com, on LinkedIn, and via the podcast. That's it from me. Until next time.